Hi everyone, my name is Ravi Prakash and this is P and C 13th class. Okay, so to start with this question, how many 4-digit numbers will have sum of digits as 16? Okay, how many 4-digit numbers will have sum of digits as 16? Right now, it's another little bit variety from the last video, right? So we'll solve it. See, A plus B plus C plus D is equal to 16, all right? Okay, it's a 4-digit number, so A, B, C, D are digits. A, B, C, D are digits. They can be from 0 to 9 only, right? So A, B, C, D are digits. First write this markup point, very important point. A, B, C, D are digits and they can be only from 0 to 9. That is, all can be less than equal to 9, right? Very important point. Okay, now, so A plus B plus C plus D equal to 16. Now it's a 4-digit number, right? It's a 4-digit number. So how to make a number 4-digit number? Right now, if I write total number of solutions, in that case, A can be 0 also, right? But I don't want A to be 0 because it's a 4-digit number. So first condition I should put is what? A should be greater than equal to 1, right? A should be greater than equal to 1. So if A is greater than equal to 1, now that means first digit of a number is 1 and 3 digits to follow. That means number is a 4-digit number now. So if A is greater than equal to 1, so in that case, A plus B plus C plus D equal to 15. All now can be 0, right? So what is the number of solutions? So number of solutions is now A plus B plus C plus D equal to 15. 15 circles plus 3 plus sign. 15 plus 3, 18C3. 15 plus 3, 18C3, right? But the problem here is, again, same thing. We have satisfied this minimum condition that, okay, A has to be 1. That means it's a 4-digit number. But again, sum of 4-digit number is 15. Sum of 4 digits is 15, right? And we don't have put any conditions here that it can be from 0 to 9, right? We have to put some condition that all the digits have to be from 0 to 9, right? So again, same thing. Out of 18C3 cases, I'll subtract those cases. I'll subtract those cases where A, B, C, D are greater than equal to 10. I don't want those cases where A, B, C, D are greater than equal to 10. I don't want those cases, right? So out of these many cases, how many cases of A, B, C, D greater than equal to 10? We can solve it. So if you can write this equation as, okay, A plus B plus C plus D equal to 15. I've written is a capital A is small a, right? Don't get confused. Just to differentiate it that I've given 1 to A, right? You can take capital A also. It's your wish, right? So A plus B plus C plus D equal to 15. And now remember that A has now 1. A has now 1, right? A has 1 now. This is very important, right? A has 1 now. So now I'm subtracting all the cases where, what is the difference between in this question and last question, right? Because then when I'm subtracting all the cases here, so now I have to subtract all those cases where A has to be greater than equal to 10. But I should not write here 10. I should not write A greater than equal to 10. Why I should not write it? I should not write it. Why I should not write it? Because A has already 1. You have given already 1 to A, right? That means in this case, if A plus B plus C plus D equal to 15, A can't take 9 also. A can't take 9 also, right? Because if A takes 9, A already had 1. 1 plus 9 is 10. So A can't be 10, right? This A can't be 10, right? A can't be 10. That's why, right? That's why in this case, if A is already 1, so you give the values as these values cannot be, A is already 1, so this whole value cannot be 10. That means I should subtract the cases where A is greater than equal to 9 for only A, because B, C, D are still nascent. They have 0, 0, 0, right? So I should subtract the cases where B, C, D are 10. But because we have given 1 to A, so in this case only, I'll give A only 9. I'll subtract all the cases where A is greater than equal to 9. Okay. So A is greater than equal to 9. How many cases? So 15 minus 9, 6. So you can write like, okay, again to differentiate A dash. So A dash plus B plus C plus D is equal to 6. Now all can be 0. Now all can be 0, right? So what is the number of solutions? So 6 plus 3, 9C3. Okay. So for A, it is 9C3, right? Okay. So 18, I should write here, subtracting the cases. So total was 18C3. So out of 18C3, subtracting A, for A it is what? For A it is 9C3. 9C3 is for A only, right? Now for B, C, D, it will be same, right? Because B, C, D have got all here greater than equal to 0, 0, 0. So B, C, D for all B, C, D is same only, right? What is for B, C, D now? So to subtract those cases where B is now for A, it was greater than equal to 9 now. And for B, C, D, I can write all are same. So for B, C, D, all can have greater than equal to 10. Correct? So 18C3 minus 9C3 minus cases for B, C, D. What is the cases for B, C, D here? So minus here, no space here, minus here. Okay. So minus. What is the cases for B, C, D here? B, C, D, what is the cases? For B cannot be greater than equal to 10. So this is my equation, right? This is my equation. A plus B plus C plus D equal to 15 and B cannot be greater than equal to 10. So do it mentally now, right? You can do it mentally for two reasons. We don't have space also here, right much. Okay, so do it mentally here. So A plus B plus C plus D equal to 10 here. 15, right? So now how many cases for B greater than equal to 10? So for B greater than equal to 10. So if I give B 10, I'm left with A plus B plus C plus D is equal to 5. A plus B plus C plus D equal to 5. Okay. Now all can be 0. So what is the number of solutions? Number of solution 5 plus 3, 8C3. 5 plus 3, 8C3. So 5 plus 3, 8C3. So 8C3 for B greater than equal to 10. 8C3 for C greater than equal to 10. And 8C3 for D greater than equal to 10. So how many times? 3 times. 3 into 8C3. This is the answer for this question. This is the final answer for this question, right? 18C3. So total number of cases minus 9C3 for A. Why? Because A already had 1. A already had 1. We have given 1 to A here to make it a 4-digit number. Okay. And my 9C3 for A, and then for B, C and D, 3 into 8C3. 3 into 8C3, right? So it's again a very good question. Okay. I only want to do in one slide because to get we are doing good questions also, and I don't want to change slide also, right? A little bit concentrate in this slide. I'm changing colors to just make your concentration better. Okay. Similar question I've given in quizzes, right? Same thing. In quizzes, I've given similar questions. Just practice there, see my video solution. It matches with your solution. You are done with this concept, right? Okay. Now, move to next question. In how many ways sum of 8 can be obtained on throwing 4 dices? 4 dices, right? Now, you could have studied some questions where there are false dice, there's not a true dice, right? But if nothing is given, so dices are that same Ludo dice. You have to assume a cuboid like a Ludo dice with like 1, 2, 3, 4, 5, 6 faces. Okay. And 6 numbers can appear. 1, 2, 3, 4, 5, 6. Okay. So now sum of 8 can be obtained by throwing 4 dices, right? So let the dices be, first dice be A, second dice be B, third dice be C, and fourth dice be D. Okay. So now A plus B plus C plus D is equal to how much? Is equal to 8, right? But conditions, put the conditions, right? What are the conditions? Dices. They are dices. That means dices will have minimum value as 1. Minimum value as 1 and maximum value as 6. Very important, right? So simply can't write A plus B plus C D equal to 8. So total 11C3 solution. No. Put the condition. There are dices. Minimum value on each dice is 1 and maximum is 6. Very important, right? So first we'll satisfy minimum condition. Then we'll take care of the maximum part, right? What is the minimum condition? All should be 1. Minimum value on all dices should be 1. So give all the numbers, all the variables or all the dices 1, 1, 1, 1. Now what I'm left with, let's solve it. A plus B plus C plus D equal to how much? 4 now. Giving 1, 1, 1, 1, 1. I'm left with 4 now. Okay. So now all can be 0. Now all can be 0. And see, if I write total number of solutions here, so 4 plus 3, 7C3, right? 4 plus 3, 7C3. So if I write total number of solutions here, it is 4 plus 3, 7C3, right? So total 7C3 solutions. Okay, total 7C3 solutions, right? But we should check here that maximum value is also 6. They should not violate it, right? So here, okay, if A plus B plus C plus D equal to 4, that means maximum value any variable. So A, B, C, D, maximum can take 4. Maximum can take 4, right? And already maximum can take 4. Okay. So A, B, C, D at maximum can take 4. And already it has taken 1 here. Already it has taken 1, right? That means 1 plus 4, 5. Maximum is 5, right? So no issue. But when the issue begins, when the number is more than 6, right? Because dice cannot have more than 6 here. So perfectly fine. What is the answer? Answer is 7C3. That is 35. So 35 is the answer. 7 into 6 into 5. So from 7, go 3 steps back. 7 into 6 into 5 divided by 3 into 2 into 1. 35 is the answer. Okay. So very good question it is. Okay. Now next question. Put the next slide. Yeah, okay. So some more variety will put here now. So if 4 dices are thrown, in how many ways we can get a sum of 11? This is a question. In how many ways you can get a sum of 11? Okay. So see, again, funda will be same. We'll solve same like this only. See, A plus B plus C plus D is equal to 11, right? A is the number appearing on first dice. B is the number appearing on second dice. C is the number appearing on third dice. And D is the number appearing on fourth dice, right? So A plus B plus C plus D equal to 11 now. I know that in case of dice, minimum value will be 1 and maximum value will be 6. Both should not be violated, right? So if A plus B plus C plus D equal to 11, all has to be greater than equal to 1. See, this kind of questions are asked in CAT 2 times. Okay, earlier also. Okay, so very important concept this is. And moreover, it grows your logic. Very important, right? So A plus B plus C plus D equal to 11. Now all are greater than equal to 1 because dice minimum value should be 1. So I'll put first all the variables as 1, 1, 1, 1. In that case, what is the value of A plus B plus C plus D now? That is equal to 7 because after giving 1, 1, 1, 1 to A, B, C, D, this is equal to 7 now. Now see here, first point is all A, B, C, D, all have now 1, 1, 1, 1 with them, right? Now, second point is if I write total number of solutions here, so what is the total number of solutions? So total number of solutions is how much? 7 plus 3, 7 plus 3, 10C3. So total number of solutions here is 10C3. But again, same thing, right? Again, same thing because 10C3 cannot be the answer because A plus B plus C plus D equal to 7. So after giving 1, 1, 1 to the dice, they have to take care of the maximum limit as well. In the last question, maximum limit was not exceeding 6. Here, if I write A plus B plus C plus D equal to 7, A can take 7 also. Right, 7, 0, 0, 0. Right, so why 0, 0, 0? Because already 1, 1 is given. So they can take 0, 0, 0 as well now. Okay. Now, A can be 6, B can be 1, C can be 1, D can be 1. So this can happen, right? This kind of cases can happen where A, B, C, D are more than equal to 6. So that means I have to subtract those cases from 10C3. So from 10C3, I should subtract those cases where A, B, C, D are. Now, I should write here greater than equal to what number? Greater than equal to what? 5 or 6? Because A has already 1. A has already, in this solution, A already has 1. So A can take 5 more. A cannot take 6, right? So I should subtract the cases greater than equal to 6. Very important concept, right? We should subtract the cases greater than equal to 6. Why greater than equal to 6? Again, because this A, B, C, D are the number appearing on the dices. Right, now A should be at least 1. So I've already given 1 number to A. Right, that means A cannot take 6 more because A can take 5 more because 1 number already given and 5 more. So one dice can have maximum value of 6, right? But I cannot give 6 to A. If I cannot give 6 to B because all have got 1, 1, 1, 1. If they can be 6 now, it will become 7, right? Because they can't be 7. Okay. So 10C3 minus A, B, C, D, that is all are greater than equal to 6. Okay. So 10C3 minus A, B, C, D greater than equal to 6. Okay, fine. So let's write this equation now, where A plus B plus C plus D equal to 7 now. Okay, so A plus B plus C plus D equal to 7. And I'm subtracting those cases where A is greater than equal to 6. Right? So I have to subtract those cases where a is greater than equal to 6. So if I give 8 6 to a, that means a dash plus b plus c plus d equal to how much? 1. Right? Now all can be 0. Now all can be 0. So if now all can be 0, what is the number of solutions? 1 plus 3, 4c3 or 4c1. Both are same thing, right? 4c1 or both 4c3, because 4c3 equal to 4c1. So 1 plus 3, 4c3, that is equal to 4c1, right? So that means there are 4 cases. 4c1 means what? Does the value of 4c1? 4c1 means 4. So there are 4 cases of a greater than equal to 6. So similarly, 4 cases of b greater than equal to 6, and 4 cases of c greater than equal to 6, and 4 cases of d greater than equal to 6, right? So total how many cases I need to subtract? 4 into 4. 10c3 minus 4 into 4, or basically I should write here 4c1 into 4. 4c1 into 4. Okay, let me, okay, 4c1 into 4, right? 4c1 into 4. So 10c3 minus 4c1 into 4 will be the answer for this question. We can solve it. 10c3 is 120 minus 16, that is 104. So answer for this question is 104. Right, this is 104. Right, very good question it is. Very interesting concept it is. Okay. Right, I hope it is clear now, this part. Okay, so what we did, a b c d should all be greater than equal to 6. This part I need to subtract because already a b c d had the value 1, right? You think in terms of chocolates, right? That a can have minimum of 1 chocolate and a can have maximum of 6 chocolates, right? Maximum of 6 chocolates. So when already you have given 1 chocolate to a, right? So you cannot give 6 chocolates to b. You can only give 5 more to b. So a can accept total of 6. So when on 1 is already given, so in this solution I have to subtract those cases where a is getting greater than or equal to 6 chocolate, because greater than or equal to 6 chocolate will make 6 plus 1 7, but it can accept what is the maximum value? 6 only, right? That's why I'm subtracting all the cases greater than or equal to 6. Small points will make a difference, right? Now this question number, this a part is 11, right? Now let me write b part as 19. You see what is the difference here now? If I write this b part as 19, question number b, sum of 19, right? If 4 dices are thrown together, in how many ways we can get a sum of 19? Now another issue will occur here, and that we should solve it. See, a plus b plus c plus d is equal to a plus b plus c plus d is equal to 19. Now since on dice minimum value is 1, maximum value is 6, therefore I should give first 1 1 1 1, right? So it should be like, now a plus b plus c plus d should be equal to how much? It should be equal to 15 now. So 15, total solution is how much? 18c3. I should subtract the cases, same thing, where a b c d are greater than equal to 6. I should subtract these cases, obviously. So if I put a greater than equal to 6 here, again a dash plus b plus c plus d equal to what? Equal to 9. So again see, again it is more than 9, right? So after giving a 6 also here, it is again 9. So again one can take value more than 6. Okay, again one can take value more than 6 here. So I have to do this step multiple times, 2 or 3 times in some questions, right? This step is not a good way to solve it. This is not a good way to solve it, right? You got it? What is the funda? Because if a plus b plus c d equal to 19, in that case I'll satisfy the minimum condition. So minimum is 1, so all are 1 1 1 1, so this is 19. So 19 minus 4, 15 now. So total solution is 18c3. In that I have to subtract all those cases where a b c d are greater than equal to 6. Again greater than equal to 6, because a b c d already has been given 1 1 1 1. They can take 5 more, but they cannot take 6. So to subtract all the cases that are greater than equal to 6, right? So if I count the number of cases of a greater than equal to 6, so again it becomes what? Now if you give a 6, again it is left with 9. Again this number is greater than 6, right? So this issue comes in 2 times again, right? So again I can solve it to one more step and we can do it, right? But sometime 2 times, sometime 3 times we need to solve, right? So in that case, this is not a good way to solve, right? This is not a good way to solve, right? What is a good way to solve? See, I'll tell you. The good way to solve is, if this question is about 19 then the good way to solve is, see, if how many dices are here? 4 dices, right? I'll tell you method here. 4 dices are here. So if 4 dices are here, then sum on the 4 dices. What is the maximum sum on the 4 dices? Maximum sum on the 4 dices can be 24. 6 plus 6 plus 6 plus 6. And the minimum sum on the 4 dices is what? It is 1 plus 1 plus 1 plus 1, 4. So minimum sum can be 4 and maximum can be 24, right? So if the number given here is near to 24, sorry, near to 4, right? Near to 4, in that case what we can do? Near to 4, or I can write what is the average of these two. So average of these two is something around what? 24 plus 4 by 2, 14. So average around 14, right? So if I can say that if the given number given here is near to 4, or I can say less than 14, then that method will perfectly work. Okay, what we were doing will perfectly work. I can just need to do it so that subtraction one time, and the question will be solved, right? The question will be solved. Or you can say it not 14 also, right? I can say it something around 14, 13, 12, this kind of number will work. I just need to do one time subtraction, that's it, nothing else, right? So half of 24 is around 12, right? So if the number is around 12 to 14, make it 12. Have patience, we're discussing a very good method now. Make it 12, around 12. If the number is around 12, okay, around 12, then that method will perfectly work. That means in one time near to 4 or around 12, that subtraction, that extra subtraction, I need to do only one time. My question will be solved, right? But if the number is near to 24, or I should say, or it is greater than 12, right? In that case we'll have to take the reverse approach. Greater than 12, then take reverse approach. So we're going to see a reverse approach here, right? So in around, first I wrote 14, then around 12, right? So I thought, okay, it's around 12 to 14, it is fine, right? 12 we can take as a limit. So if 4 dices are thrown, so somewhere, let's say, what is the maximum sum? Maximum sum is 24, minimum is 4, right? So let's say, let's do around half of the maximum sum, that is 12. So around 12, if you take the value, you have to do that subtraction only one time, around 12, 13, 14, anything, right? You have to do the subtraction only one time, right? But if you have to take this value, if it is more than 12 or 13 or 14, or it is near to 24, then you have to take the reverse approach, right? Note this point, because we're going to delete this slide, and then next slide will solve the question, right? Or we can solve this slide only, no issue. We can solve in this slide. Okay. What is the reverse approach? So reverse approach is a plus b plus c plus d is equal to 19. Now you can write this a as, this capital A as 6 minus a. Why 6 minus a? This is reverse approach, right? 6 is the limit, so we're going for reverse now. Okay, since it is near to the maximum limit, so we're going to reverse. So keep a as 6 minus a, write b as 6 minus b, write c as 6 minus c, and write d as 6 minus d. Okay, and sum of these 4 will be equal to how much? Equal to 19, right? So you get here, therefore you get a plus b plus c plus d is equal to 5. Now listen here very carefully. If a plus b plus c plus d equal to 5 here, so in that case, so see, if I take all the, now this a can be 0, this a b c d all equal to 5, right? Let me write here this equation now. So this a plus b plus c plus d is equal to 5. This a plus b plus c plus d is equal to 5, right? Now all this a, b, c and d can be 0. All this a, b, c, d can be 0, right? So if this a, b, c, d can be 0, what is the answer? Answer is 8c3. Okay, now check what does this mean here. It means that if a is 0, what is the actual sum on dice? So if A is 0, actual number of dice is what? 6 minus 0, that is 6. Okay. If B is 0, so actual value in dice is what? 6 minus 0, that is 6, right? That means if A plus B plus C plus D equal to 5, so in the reverse case, it will take care of capital A plus capital B plus capital C plus capital D equal to what? 19, right? Because we're just subtracting it, right? Now see, one case, just we can discuss one case here. Suppose A is 1, B is 1, C is 2, D is 1. So what are the number on dices? So number on dices is what? 6 minus 1, 5. A is 5. Okay, A is 5. You can write it here. A is 5. 6 minus 1, B is also 5. 6 minus 2, C is 4. D is again 6 minus 1, 5. 5 plus, if this is the one case, 1, 1, 2, 1, it corresponds to this number. 5 plus 5 plus 4 plus 5, 19. Right? But what we have to do, we have to just count the number of cases. I'm not interested in any values, right? I'm not counting, okay, what, not writing the values 4, 5, 6, not values. How many cases are there for when there are sum of 4 variables on a dice is 19, right? Sum of 4 dice thrown is equal to 19. How many cases here? So this number of cases are same as the number of cases when a small a plus a small b plus a small c plus small d equal to 5. How to achieve? Just reverse this. Write capital A as 6 minus a, write capital B as 6 minus b, write capital C as 6 minus c, like this, equal to 19. You'll get the answer. Okay, so what is the answer? Answer in this question is 8C3 is the answer for this question. Right, wait. Just let me discuss one more problem here. It will be more clear now. Now, this C is how many ways we can get a sum of 21. If 4 dice are thrown, in how many ways we can get a sum of 21 now? See, for 21, again, if you see 4 dice are thrown here, then maximum sum is equal to 24 and minimum sum is equal to 4. This first will observe, right? Then it is near to 24, or it is more than the average of these two, or it is around more than 12, 13, 14, right? So it is like, it is in the next half. 4, one side is 4, one is 24. This is the middle value somewhere, and this 21 is obviously in next half, near to 24, right? This is 4, this is 24, this is the middle value. So if this is 24, so 21 is in next half, right? That means in next half, if it is close to maximum sum, take the reverse approach. What is the reverse approach? So reverse approach is, okay, first write this equation as a plus b plus c plus d is equal to 21. And then reverse it. Write a as 6 minus a, write b as 6 minus b, write c as 6 minus c, and write d as 6 minus d. Okay, that is equal to how much? 21. Therefore, a plus b plus c plus d equal to 3. And since all can be 0, so this number of cases, how many number of cases here? 3 plus 3, 6C3. So 6C3 is the answer. So 6C3 cases here also, and in the same case, each case corresponds to the actual number of dice, right? If A is 1, B is 1, C is 1, D is 0, then actual number on A dice is what? 6 minus 1. 6 minus 1, 6 minus 1 and 6 minus 0, right? So just try to count number of cases. So it's a good method. It's a very good method to do this kind of question. Okay. Now put some variety here. Put some variety, and I'll put variety like, I'll put question D and I'll make 15. In 4 dice are thrown, in how many ways we can get a sum of 15? Now see here. Again same thing. You can directly write now it is close to the maximum sum, or it is in next half, right? So what you can do is, to 15 you can take, right, suppose 6 minus A plus 6 minus B plus 6 minus C plus 6 minus D equal to 15. Directly reverse it, right? Because you can see it, 15 is in the next half, right? Minimum sum is 4, maximum is 24, 15 is closer to 24, right? That's why take it in the reverse way. So here A plus B plus C plus D is equal to 9. Right? Now issue will come here in this case, because again same thing, the maximum value on a dice cannot exceed 6. Okay, so maximum value on a dice is 6, minimum value on a dice is 1, right? So in this case, A plus B plus C plus D equal to 9. So to subtract, if I write this total number of solutions as 9 plus 3, 12 C3, and to subtract all the cases where A, B, C, D are what? A, B, C, D values are what? They are greater than equal to which value? So A can take C. A can take a maximum of 5. A can take a maximum of 5, because 6 minus 5 will be 1, right? So you can write here a small a or a small b, a small c, and a small d can take maximum value as 5, because in that case 6 minus 5 will be 1. It can't take 6, because if a small a is 6, then what is the actual number of dice? Actual number of dice, 6 minus 6, it is 0. 0 can't be there on dice, right? That's why 12c3 minus a plus b plus, so a, b, c, d, which cases I need to subtract? So I need to subtract the cases where this a, b, c, d are maximum it can take 5. So it should subtract all the cases starting from 6. So it should not be greater than equal to 6, right? So basically I have to count here which cases are here that is not greater than equal to 6, right? So from 12c3 I'll subtract the cases which are not greater than equal to 6. Okay, so just count it. So you can count it easily. A plus b plus c plus d is equal to 9. How many cases of a greater than equal to 6? So put a greater than equal to 6. You get a dash plus b plus c plus d equal to 3. How many cases? 3 plus 3, 6c3. So 6c3 cases for a. Similarly for b greater than equal to 6, again 6c3 cases. For c greater than equal to 3, again 6c3 cases. For d greater than equal to 3, again 6c3 cases, right? So the answer is 12c3 minus, how many cases I need to subtract? 4 times 6c3. 12c3 minus 4 into 6c3. 12c3 minus 4 into 6c3. This is the answer for this question. Okay, 4 into 6c3. So I hope this part is clear, right? We're discussing very good concepts here, right? This very important concept. I hope this part is clear now. You can just verify the answer if you want. Just solve this question. 15 is like in somewhere in the middle, right? 4 and 24. So what you can do is try from forward also. Okay, there also you get the answer. You'll get the answer there also. Okay. Okay, thank you. We'll see you in next video.